Now we're going to look at congruent angles. We looked at congruent segments in a previous lesson. Remember, those were segments that had the same measure or the same length. Congruent angles, similar idea, just now with angles. These are going to be angles that have the same measure. If I want to say two angles have the same measure, there's a few different ways this can look. First of all, I want you to draw two little angles here. Try to make them look reasonably similar for yourself. I'm going to label this angle A and this angle B. When we dealt with congruent segments, we would put the little dashes in it to mark that they were congruent. In angles, though, we put a little arc. So if you have a little arc in each, that means they're congruent. 2 arcs congruent, 3 arcs congruent, and so on. And then how you would write this as a statement is you would say angle A is congruent to angle B. So you'd use your little congruent angle symbol. And again, this means they both have the same measure. So for example, if they were both 45 degrees, right, those would be congruent to each other. An angle bisector. So when we dealt with a segment bisector went through the midpoint. Angles don't have midpoints. So an angle bisector is simply going to cut our angle in half. So it is anything that cuts an angle into two congruent angles. And I'm just going to use my symbol here because we have to get used to our symbols. So remember, your congruent symbol is the equal with a little squiggle above it. So let's look at this diagram here on the right. Here we have angle X, W, Z, and it has ray WY going through like the center of it. So if I wanted to say that ray WY bisected this angle, there's a few different things I would see. First of all, my angles would be congruent, so you'd have two little congruent angle marks. And then again, they would be congruent on either side. So for example, maybe this angle is 45 degrees and this angle is also 45 degrees. And that cuts it in half. So what we would say about this picture is that ray WY bisects angle XWZ. So that's how that would be written. And then just keep in mind here, if I ask you to identify the angle bisector, that's this ray. So ray WY is your angle bisector. Then the angle addition postulate, very similar to the segment addition postulate. We're still going to apply our part plus part equals whole strategy. So this says if point B is, all right, one second. Okay. If point B is on the interior of angle ADC, so here's angle ADC, point B is on the interior because it's between A and C here. Then the measure of angle ADB plus the measure of angle BDC is going to give us our whole angle. So again, here we have the measure of angle ADB. So that's this angle here plus the measure of angle BDC, right? That's that angle there, is going to give you the entire angle measure, right? This whole thing, which we're going to call angle ADC. So this is again part plus part equals whole. And now let's look at some examples with that. So example 1 says write 4 names for the angle. So this is again just practicing our angle labeling. Remember, you can name it with 3 letters vertex in the middle, just the vertex if it's a standalone angle, or a number that's in the middle. So if you wanted to name it with 3 letters, you could say angle X, Y, Z. You could say angle Z, Y, X. Either is fine. Then you could also name it with your vertex because it's a standalone angle. So we could say angle Y, or our number in the middle. So angle 1 is also an option. For number 2, it says, why is angle Q not an appropriate name for any of the angles shown? Well, this is similar to what we talked about on the front. If you say angle Q, I won't know which part you're talking about. This is not a standalone angle. You might be talking about angle PQR, angle RQS, or the whole thing. So we're going to say Q is the vertex of multiple angles. Numbers 3, 4, and 5, we're going to use this diagram on the right. So I know that there's a lot going on in that picture, and if you ever see a picture that's just a little complicated, cover up the information you don't need. So if I'm looking for the vertex of angle 5, all I care about is angle 5. So I'm going to highlight it. Nothing else like down here or any of that stuff matters. So just focus on the information you need. So for the vertex of angle 5, remember that's where your 2 rays intersect. Where it comes to a point, that's going to be point M. Then the sides of angle 6, again, the only angle that matters here is 6. So I'm going to highlight angle 6. Well, we can see angle 6 originates from point N and then goes out. So from N down and to the left, and from N down and to the right. So we just need to name those 2 rays. So we could say ray NM. Remember, always start with your vertex there, or ray NO. For ray NO, since this continues on and on indefinitely, you could say ray NO, ray NP, or ray NR. That's up to you. I just pick the one that's closest to it. And then another name for angle QPR. So QPR. Well, I'm going to name this in 2 other ways. First of all, if you have your 3 letters, you can always just reverse them. Keep your vertex in the middle. So that would be angle RPQ. Or we also have this little letter in the middle, or number in the middle, we could also say angle 3. We can't say angle P because that's the vertex of multiple angles. Okay. Moving on to number 6, find the measure of angle BAD. So what I like to do with this is label or highlight your picture. Highlight the angle it wants you to find because it's going to vary from problem to problem. So if I want to find the measure of angle BAD, that's the whole thing. Well, this is a angle addition. We have a part and a part. We have to add them up to get the whole. So we're going to do the measure of angle BAD equals 31 plus 24. Add those together to get 55 degrees. And then if you look at 7, it says the measure of angle EFG is 130 degrees. Find the measure of angle HFG. And if you take a look at your picture, angle EFH is labeled as 86. Now this is a scenario where you're given additional information in your directions that's not labeled in your picture. Always label your picture. So angle EFG, that's this whole thing, is 130 degrees. It wants me to find angle HFG. So with this one, I know the whole measurement and I have part of it. I need to find the other part. So this is like the angle addition postulate, but you need to work backwards. So to find the measure of angle HFG, I need to subtract. I'm going to take 130 minus 86, which is going to give me 44 degrees. And you can always add those up at the end to double check your answer. Number 8, find x. So for this one, we have 2 different angles labeled here. We have angle FGE is 2x minus 18, and angle FGH is 4x. Well, we need to solve for x. We need to write an equation here. Just like what we did with segments, where we have, when we set up an equation, it's either part equals part, because they're congruent, or it's part plus part equals whole. We're going to have that same situation with angles here. So it's going to be very tempting to be like, oh, I have 2 things, set them equal. But we don't know that these are equal or congruent. There's no little arcs to tell us. We're not told we have a bisector. We don't know that they're congruent. And then you might also say, but Mrs. Geyer, I also don't know what the whole measurement is. But you do. Think of your types of angles. Down here along the bottom, we have a straight angle, angle EGH, which has to be 180 degrees. So this angle down here has to add to be 180 degrees. So we're going to do part plus part equals whole. And our one part is 2x minus 18. Our other part is 4x, and our entire measurement is 180 because we have a straight angle along the bottom. Now combine your like terms. 2x plus 4x is 6x minus 18 equals 180. Add your 18 over. 6x equals 198. And divide to get 33. Okay, so that's a part plus part equals whole problem. Now for this next one, number 9, it says the measure of angle PRS is 98 degrees. Find the measure of angle QRS. So you're again given addition information in your directions. It's not labeled in the problem, so we want to do that. It's telling us the measure of angle PRS is 98. So that's this whole thing. PRS is 98. And then we're told that angle PRQ is 3x minus 8, and angle QRS is 2x plus 6. So again, very tempting to set them equal to each other, but they're not marked as congruent. We don't know if we have an angle bisector. Nothing is telling us that they are congruent, so we cannot assume. But we do know the whole angle is 98. So this is going to be another part plus part equals whole problem. So my one part is 3x minus 8. My other part is 2x plus 6. And the whole thing is 98. And now let's simplify. 3x plus 2x is 5x. Negative 8 plus 6 is negative 2 equals 98. Add your 2 over. 5x equals 100. Divide to get 20. Now, you're not done. Well, you might stop here. Read your directions. It said you need to find the measure of angle QRS, which is why I always like to label that and highlight it. So you're not quite done. We know what x is, but we now need to plug x back in. So I'm going to say the measure of angle QRS equals, and plug in your 20, so 2 times 20 plus 6. 2 times 20 is 40. 40 plus 6 is 46. Two more in this video. I'm just trying to show you as many different situations as I can think of, so you're prepared. So number 10 says the measure of angle JNM equals 103. Find the measure of angle JNK. So again, if you look at your picture, we're given additional information that is not labeled. So let's label that. Angle JNM is the whole thing. So that's 103. And we need to find angle JNK. That's just empty one there. We're given that angle MNL is 24 and angle LNK is 32. So this is, again, we know some of the parts, we know the whole, we're missing the other part. So this one we're going to subtract. So the measure of angle JNK equals, I'm going to take 103 and subtract what I have, which is 24 plus 32. Now you can always add your 24 plus 32 separately and then subtract it out. I just kind of like to write it all out at once for you guys. So that would be 103 minus 56, which is going to give us 47 degrees. Okay. And then last one for this video, number 11. In number 11, it just says solve for x. You're given that angle YXZ is 7x minus 10, and angle ZXW is 2x plus 1. Now you might be looking at it going, well, okay, I know they're not congruent, but what are they supposed to add up to be? Well, look at your little right angle box here. That means 90 degrees. So my two parts will add up to be 90. So let's write this down. Solve for x. We're going to do part plus part equals whole. So 7x minus 10 plus your other part, 2x plus 1 equals your whole, which is 90. Now simplify. 7x plus 2x is 9x. Negative 10 plus 9 is negative 9 equals 90. Add your 9 over. 9x equals 99. And divide to get 11. And this one, it just says solve for x, so you don't have to plug it back in. And then in the next video, we're going to go to some that have angle bisectors.